All right, so welcome everyone. Thank you for joining today's webinar on Owners Engineering. Today's webinar is hosted by Detra Solar, a global solar and storage design and consulting firm. Today's webinar will be hosted by me. My name is Simona. I'm the head of marketing at Detra Solar, and by two of my colleagues. So just for everyone to be on the same page regarding today's webinar, instead of asking questions in the chat or raising hand, if you could please kindly join our Slido page. So you either go to slido.com and enter the code that you see on the page, or scan the QR code with your phone right now, and you will be able to leave questions all throughout the presentation. So we can answer them at the end of the presentation during Q&A. Or if you leave next to your question, if you leave your contact details, we will make sure to answer these questions after the webinar via mail. We will also show you the opportunity how you can book a meeting with ourselves later on in the meeting as well. Next slide. Right, so today we will meet the speakers. We will go through owners engineering and what that is and how that looks throughout the different stages of your project, because I believe lots of people today are joining from different companies with different requirements. So we will try to answer all of your scope, and we will have a short Q&A session. So again, please scan the code and leave your question. Right, so I would love to introduce my colleagues. So that is Serkan, Kaniturk, our CTO, and Ryszard, who is the lead project engineer and specializing in battery storage solutions. So I'm handing it over to you guys. So hello, Ryszard.
Hi, and hello, everyone. Thank you for joining. I'm happy to see so many attendees joining us today. My name is Ryszard, and I'm a lead project engineer responsible for BESS at Detra Solar. A couple of words about my experience. In the last past years, I've been supporting development of more than 3 gigawatt hours of BESS sites and participated in construction design of several projects. Those range from standalone sites, hybrid sites, and retrofits. And I will be sharing today my observations on BESS projects, which became an indispensable part of our renewable industry with its own challenges. I like to see my role in this puzzle is that to ensure that the design, construction, and quality aligns with owners' goals, standards, and expectations.
Great, thanks, Ryszard. Hi, everybody. I'm Serkan Kaniturk, a chartered engineer. Next year, actually, will mark my 20th year in the solar industry. Over the past 2 decades, I have had the privilege of designing and managing many solar projects across Europe and the UK. I actually still remember my very first design. It used 25-watt peak BP solar panels. So let's fast forward to today, and we are working with panels approaching 700-watt peak. It has been an incredible journey to witness and contribute to this evolution for me. And one of the highlights of my career was designing the UK's very first ground-mounted solar project, which was a 5-megawatt plant for Toyota car factory back in 2008. So alongside project work, I have also contributed to developing UK standards and codes of practice for solar and storage systems. So this is a little background of mine. So now let's talk about Detra Solar. We are a design and engineering consultancy that focuses on large-scale solar and energy storage projects. Over the past years, our team has built up extensive experience, not just in photovoltaics, but also in battery storage and full system integration. Our work covers the full life cycle of a project, from feasibility through detailed engineering all the way to operational readiness. To date, we have delivered designs for almost 50 gigawatts of projects across multiple continents. That track record means we have seen a wide variety of technical and commercial challenges and problems, and we know how to help owners reduce risk, stay compliant with standards, and ultimately optimize performance. At the heart of Detra Solar is a commitment to innovation, reliability, and also engineering excellence. And that's why we are trusted these days to support some of the world's largest or most complex solar and storage projects. So what is owner's engineering? For those less familiar with these terms, what exactly is an owner's engineer and why does a project owner need one? So this is the question. And the answer is owner's engineer is an independent technical advisor representing the project owner. His main duty is to protect the investor's interest on cost, schedule, quality, and also performance. As you all know, utility scale or large scale solar and storage projects can be extremely complex. Success actually not only depends on EPC delivery, but also on how risks are managed from feasibility through operation. And that's exactly where owner's engineer protects the investor's interest by ensuring the project is aligned with owner's requirements, contract specifications, quality standards, and safety and operability criteria. So we now we know today's audience includes professionals from a wide range of departments, each of you responsible for different aspects of project delivery. And before today's webinar, we have asked some of you which project stage would improve the most project outcome, and the results indicated 4 stages which are seen in the slide. Over the next 15 minutes, Ryszard and I will walk through those key stages of a typical solar and storage project from early feasibility all the way through the project handover. And at each stage, we will try to highlight the common risks and challenges faced by project owners. And more importantly, we will show how owner's engineer adds value by mitigating those risks, protecting project outcomes, and also ensuring long-term performance. So the first stage is the feasibility and development. At the feasibility and development stage, projects can get into trouble very quickly. I'm sure you all experience that. We often see over-optimistic yield assumptions, poor site selection, or even some mismatched technology. These early mistakes usually lock in long-term underperformance and higher costs. And this is where the owner's engineer brings discipline, because owner's engineer validates irradiation data, site conditions, and grid feasibility to make sure the site is not only technically viable, but also serviceable and future-proof. Owner's engineer also reviews geotechnical and environmental studies, permitting requirements, and OEM technology differences. For instance, BESS enclosures and PCS skids can vary a lot in size and interfaces. And if that isn't addressed upfront, it can cause major integration issues later. And after that, owner's engineer also delivers a clear feasibility report with balanced technical, environmental, and financial risks, which is very, very important. That gives the owner a solid basis for decision-making and confidence to move forward. So with that, I would like to actually hand this over to Ryszard. He can just talk about a real case project actually that we've done recently.
Yeah, thank you, Serkan, for that. So yeah, when it comes to feasibility and development, I would like to present to you a case we recently had in Germany. It was a 50 megawatt 4-hour battery project. To give you some context, the site itself was extremely tight with difficult topography, and this, in our eyes, presented a big area of concern, because without a substantial grading works, the site would not be feasible. When it came to the design, it was also based on a fairly uncommon equipment footprint. Definitely not something we see as mainstream. On top of that, there was no proper definition of the usable capacity. Only the nominal figures were being referenced. And the project also lacked an augmentation strategy. So all of those combined created quite a significant long-term risk for the project success. For this project, we stepped as the owners engineers at the early stage. We identified the topography challenges and recommended design optimizations so that which minimized the environmental and construction risks. We also recommended at this stage a more vendor-agnostic design approach, making sure, or rather not letting the site layout getting locked into one OEM, very specific and unique container footprint. Another important intervention was to verify that design assumptions are based on the usable capacity and not on the marketing nameplate values. This was crucial finding as not usable capacity, but the nameplate values were assumed in the system modeling. Lastly, we highlighted the importance of defining the augmentation strategy early on to make sure space is allocated for that on the site. So by addressing those points upfront, we allowed flexibility to switch vendors without major layout updates, potentially avoiding costly and timely redesigns, and gave lenders confidence that the system would meet her performance expectations over its lifetime. There are some repetitive takeaways from this case. I'll name three. First of all, don't underestimate how much site conditions, especially topography and OEM footprints, can constrain your options later on. Because once permits are granted, it might be very difficult or challenging to amend the layout. Secondly, always define usable capacity in your projects and not just nominal ratings, because at the end, those are the ones that drive the revenue. And often usable capacity is significantly lower, as we know, than the nameplate due to depth of discharge and state of charge limits. And lastly, I would recommend to define the augmentation strategy or capacity retention from the day one, because otherwise you risk your asset being stranded and not able to deliver on the contractual obligations. And it's also important to really focus on that from the early stage, because if augmentation is needed, you really need to also reserve some space for that on your site. Now I would like to give the microphone back to Serkan, and we can talk about the next very important design stage.
Thank you, Richard. That was a great example. So in the next stage is the design and procurement phase. So in the design stage, we often see EPCs optimize for the lowest cost rather than the long-term operability. That can actually lead to over or under engineering, layout inefficiencies, interoperability issues between PV inverters or PV panels or inverters, and sometimes storage as well, or even grid compliance gaps. So these early shortcuts can lock in performance problems for many years. And on the procurement side, the risks are just as significant. We see vendor lock-in specs that don't meet IEC or local codes, and big variations between best suppliers in terms of safety, HVAC, and warranties. So add to that long equipment lead times, the vague guarantees, hidden costs, and weak contract terms, and owners are mainly exposed to major financial and schedule risks, actually. So this is exactly where, again, owners engineer adds value by reviewing designs for constructability and operations and maintenance, developing clear specifications like minimum functional specification, or conducting vendor due diligence, supporting fair tender evaluations, and making sure contracts include the right protections. So that independent oversight keeps the owner in control and protects the long-term performance. So I would like to give another case study here. On a recent 70 megawatt solar project in Europe, the EPC proposed a layout that actually minimized upfront capex by reducing row spacing and access corridors. So on paper, actually this cut land use and saved about 1% of the construction cost, which is true. However, during our owner's engineer review, we identified two major risks: restricted access for maintenance vehicles and also increased shading losses in winter months. So both issues would have raised operations and maintenance costs and reduced annual yield. So we recommended a minor redesign, slightly increasing row spacing and adding dedicated access routes. And maybe without overwhelming you all with all this math, I can say that we proved this by running a side-by-side analysis of the EPC's layout and our revised layout, using standard O&M cost benchmarks and shading simulations. We show that while the redesign actually added just less than 1% to capex, it also reduced long-term operations and maintenance costs by 5 to 7% through easier access and fewer outages, and also improved energy yield by about 1% in PVcase. So if you can imagine, over the 25 years, that will translate into several million euros of additional revenue for the owner. And the owner's long-term interests here were protected with a more reliable, serviceable, and higher performing project. The next slide is the construction oversight phase. So during construction, the most common issues I guess you also encounter are around workmanship and quality. Things like loose torquing and misaligned trackers or damaged cables may look minor at the time, but they often translate into major performance and reliability issues later. We also see risks from quite poor quality assurance and quality control processes, undocumented checks, and delays in especially civil works, also equipment delivery. On top of that, safety practices are not always enforced consistently, and responsibilities between different parties can become blurred. This is where, again, the owner's engineer adds real value. Owner's engineer provides independent QA, QC oversight, supervise installation quality against design and also workmanship, and track schedule progress. In addition to that, owner's engineer also can verify that construction matches the design work, which is extremely important, and also with the minimum functional specification or technical specification. And that will help coordinate between the EPC contractors and the owners. Again, we would like to share a quick slide here. Richard, please, I'll hand this over to you.
Thank you. You talked a lot about quality assurance, and my slide is just about that. So I would like to go back to what the first point, which was a misleading definition of ready to build. And I hope some of you will agree that it can be a true bane of existence for EPCs and project owners, creating a lot of friction. Typically, when starting a project, EPCs often skip crucial due diligence. They may fail to confirm that the land surveys are in place, that all permits are in place, and that the site is truly suitable for the plant equipment and construction. So in that specific case, it was a BOP contractor who received a ready-to-build package and assumed that the site has been fully engineered and consented for the selected OEM. And from the bird's eye view, well, the battery containers on site looked exactly the same, just a typical 20-foot container. However, in reality, the procured BIOS equipment had very different grouping and spacing requirements than those assumed in development. And this critical feature was had not been picked by the BOP contractor, and they actually started mobilizing. We engaged, or we were contracted as owner's engineer quite late, and performed the independent design review just before construction, and quickly found out the critical misalignments between the actual manufacturer requirements and the site plan. We also uncovered that cable trenching designs exceeded grouping limits defined by IEC standards, which is a fairly common situation on a tightly packed bed sites. This single fact, if left uncovered, could have led to overheating, performance losses, and even failure down the line. So by catching those issues before mobilizations, or stopping the mobilization, we avoided expensive mid-construction redesigns and months of wasted EPC labor waiting for re-permitting. We also requested thermal trend simulations and design updates to improve reliability of the entire system. This way, the design was corrected before EPC actually broke the ground. Once again, some universal lessons learned from that case. A project really isn't ready to build until actual procurement equipment is verified against approved designs. The best sites really need to consider OEM access. This is often skipped from our experience, which risks long-term serviceability of the site. And often a common issue, which is cable routing, which doesn't follow general standards. And in that cases, you really need to go an extra mile to verify if those systems are safe and compliant. As we all know, finalizing construction is not the end of the journey. It's rather the beginning of the next very important stage, which is commissioning. And with that, back to Serkan.
Great, thank you. Yes, commissioning is another important stage. At commissioning, the project's performance is actually going to put to the test. Common issues include incomplete or rushed testing, such as PR verification. So for those who doesn't know what PR is, like performance ratio calculations, verification, inverter performance, or best functionality. Grid compliance gaps are also quite frequent, like protection settings or reactive power tests may be missing. SCADA systems and sensors may not be properly calibrated, and alarms may be misconfigured. So these gaps can lead to disputes over warranties or performance guarantees if the system doesn't deliver as promised. So again, the owner's engineer here will add value by supervising and validating all commissioning tests, ensuring grid code compliance, and checking SCADA and monitoring systems. Owner's engineer will provide independent performance assessment so owners can enforce warranties confidently. And maybe also, again, owner's engineers, I think this is very, very important area before I actually forget about that. Owner's engineers' job is to ensure all as-builts, O&M manuals, and trainings are complete. This is extremely important, and this is usually not really a great area in our industry. You know, we see that as-builts do not match what is being built, and the handover documentation are really bad and missing lots of important details. I think this is very important, and making the handover smooth and setting up the operations team for long-term success is crucial. And I think our industry is definitely missing this. So, you know, with the last phase of project commissioning and handover, we are kind of like concluding our presentation today. We wanted to keep it short and sweet. I now would like to summarize what we just discussed in the last 20 minutes, 27 minutes, and highlight the importance of owners engineering once more. Across the project life cycle, from feasibility to commissioning, the owner's engineer protects the owner from technical, commercial, and schedule risks. Independent oversight will definitely ensure quality, compliance, and long-term performance, and ultimately safeguarding the financial and operational success of the project. So thank you again all for listening. With that, we can now move to the Q&A session. I guess due to the limited time, we will only be able to take a few questions that you have. So let's see if there's any questions, Simona.
Yes, well, thank you very much, Serkan. It's been really informative. We have quite a few questions, so I'm just going to read some of them out. Right, so the first one is, why would you need an owner's engineer if you work with an experienced EPC contractor? Serkan, is that something that you can answer?
Yes, sure. Well, that's a good question. It's a fair question. So a good EPC is essential, but as I just said earlier, their focus is naturally on delivering the project at the lowest possible cost and risk to themselves. That doesn't always align with the owner's long-term interests. So our role as owner's engineer is to act as an independent check. And with that, we review designs, procurement choices, and construction quality to make sure the project is not just built, but built for 25 years of reliable operation. So owner's engineer actually kind of complement the EPC by protecting the owner's side of the table, I would say. Hope it just answered the question.
Right. Hopefully we have answered the question that the person has asked. We have quite a few more. Another one is, why can't developers or IPPs just do this in-house? I assume that's owner's engineering.
Yeah, sure. Could you repeat the question?
Absolutely. Why can't developers or IPPs just do this in-house?
Yeah, so some companies do have actually strong technical teams, and that's great. That's fantastic. But these projects, the large-scale projects, are complex with some evolving technology and supply chain problems and challenges. Owner's engineer can bring very focused expertise and experience from different type of projects that they deal with every day. Also, I guess because owner's engineers are independent, they're not really tied to a specific vendor or contractor or supplier, whatever. So in most cases, I guess that would work very well. And beside that, owner's engineers normally work side by side with in-house engineering teams of the companies. So then in-house engineers handle the big picture strategy, and owner's engineer dig into the technical details and vendor checks or supplier checks or contractor checks. So for me, it's a very good partnership, and it will work much better this way.
Thank you, Serkan. We have quite a few more questions. And another one is, what are the most common mistakes you see in BESS project development? I think that would be for Ryszard.
I can definitely take this one. That's a very good big question. On the top of my head, well, one of the biggest ones is poor site selection. So that's a mistake from the very early stage of the project. I've seen some sites which were more suited for to be a ski slope than sites suitable for BESS. Underestimating how much capacity can actually be filled on the site. We've seen some developers just filling the site up to the brim without thinking about constructability, safety corridors. The next one is civil and electrical designs being developed in isolation. And I think one of the biggest ones, which creates definitely like the most chaos and risks, is the lack of clear owner's requirements. So really, the main message here for me would be to get the fundamentals right, to really set the expectations, have realistic layouts, and coordinate design reviews. This simply saves so much time and money if done correctly at the beginning, than if those are to be fixed later on the project.
Thank you, Ryszard. I think that was very clear. And we have one more question. At what stage would you typically see the owner's engineer being involved in a BESS project? I think that's for you, Ryszard.
I can also answer that. It's a very good question, and it really depends. Just as Serkan was saying before, it really depends on the technical capability of your own team, on your experience. But in my honest opinion, the earlier the better. As with every project, the corrections are the most impactful and also cheapest at the very early stage. Because when we're getting closer to construction, well, then the owner's engineering influence becomes more like an acupuncture. Small but still important corrections rather than big course changes. So another key reason to involve owners engineers early would be to align contractors. In BESS projects, we have usually quite a lot of parties, integrators, BOP, grid contractors, if we're talking about the design stage. And it's easy for the gaps appear in their individual scopes. So the owner's engineer function would be to make sure that those responsibilities are clearly defined and coordinated, so that nothing falls through the cracks. So all that reduces change orders, disputes, delays, and most importantly, as we're saying, it protects owners' interests in the whole life cycle of the project.
So thank you very much, everyone, for the presenters and to all of you that left the questions. We will answer everyone's questions if you guys can just scan the QR code that we have on the screen. In that case, you can send a direct message to us at Detra Solar or book a meeting with one of our consultants. We will make sure that Serkan or Ryszard are joining the consultation if you request specifically for them. So you can either go to detrasolar.com, contact us, or scan with your phone right now this QR code, and we will answer all of your questions, anything that you might have, and give you a consultation with your exact requirements. So thank you all for joining. Thank you very much to our speakers, and let's keep in touch. We will contact you very shortly. Thank you, everyone.
Thank you.
Thank you.